What if the entire internet were stored in DNA? Every video, website, cloud backup, meme, and forgotten forum post, encoded not in servers, but in the same molecule your body uses to store genetic instructions. Instead of data centers spread across the planet, all of human online knowledge sits in one biological archive. How big would that physical hard drive actually be? To make this answerable, we need rules. Let's define the entire internet as roughly 120 zettabytes of data, or about 120 trillion gigabytes. We'll assume extremely good compression and strong error correction. No science fiction tricks, just chemistry working at its theoretical limits. DNA turns out to be absurdly efficient. In theory, 1 gram of DNA can store about 215 petabytes of data. That's hundreds of millions of gigabytes packed into something lighter than a paperclip. Scale that up, and storing the entire internet would require roughly 558 kilograms of DNA. In terms of physical space, that's shockingly small. That much DNA would occupy about half a cubic meter, around the size of a large refrigerator, or, put differently, about half a bathtub. At first glance, it looks like the internet could fit in your bathroom. But this is where a real what-if answer stops being neat. DNA isn't stored as a dry powder. It's kept in water-based solutions with stabilizing chemicals to prevent it from degrading or tangling. Once you include the liquid and buffers, your bathtub grows into something closer to a walk-in freezer, or a small swimming pool filled with extremely expensive biological soup. The internet still fits, but now it sloshes. Reading the data introduces another problem. Sequencing DNA generates heat through massive numbers of chemical reactions. If you tried to read the entire internet at once, you'd create enough heat that, without industrial cooling, parts of the DNA bath could overheat, briefly turning the internet into a high-information hot tub. Then there's the issue of errors. DNA slowly degrades, and background radiation exists. Given enough time, a stray cosmic ray will flip a bit. It won't erase everything. It will erase something specific, a random photo, a corrupted article, or possibly the entire year 2014. Humanity survives. Vine does not. This is the realization often associated with Randall Munroe. The calculation didn't solve the problem. It just revealed which part fails first. And finally, there's one more problem no amount of compression can fix: access time. In a data center, you get your meme in milliseconds. In a DNA bathtub, the data isn't neatly indexed. It's scattered across billions of microscopic strands. To retrieve a specific YouTube video from 2008, you'd have to physically locate and extract the correct DNA sequence from the soup. Unless you own a very fast robot with a very small pipette, buffering that video wouldn't take seconds. It would take 3 to 4 business days. So yes, the entire internet really could fit into something the size of a bathtub. But the ultimate bottleneck isn't space, heat, or even radiation. It's searching through the bathtub without spilling it.